Okay, Honors Algebra 2 today is piecewise. It's not a section in the book. It's actually an extension, so it is in the book, but it's to find it, it's going to be chapter 2. It's after a section before the next section, kind of like just an extension. That's why we have it labeled that. Piecewise, the goal is to can you graph step functions, and then can you graph piecewise functions, two different kinds of piecewise functions. We just got done with a line of best fit, and then tomorrow will be absolute values. Piecewise function is a combination of equations, each corresponding to a part of the domain. So your domain tells you what part to graph. So it's more than one equation for one situation. That's another way of saying that. There's two major kind of piecewise functions we'll talk about. The first one is a step function, which pretty generic equation is a piecewise function that resembles steps. It looks like stair steps. So it's going to be looking like this. It will not have the vertical lines because we need it to be a function, but it's looks like stairs, and we'll talk a little more about that. We will have some open and closed circles on that too to make sure we see how it is a function. A specific kind of step function is called a ceiling function. A ceiling function is an example of a step function where every real number x, f of x, is the smallest integer greater than or equal to x. Round f of x up to the next integer is another way of stating that. So it's a complicated definition, but it comes down to you are rounding which way, and for ceiling functions you're rounding up to the ceiling. So we're taking y and we want to round it, we want it to be the smallest integer greater than or equal to the x, so basically you're rounding up to the next integer. There's another kind of equation called the greatest integer function, which it says greatest integer, but you're actually going to round down. So you're rounding down here. The greatest integer means you round down to the next greatest integer. So if I had, for this one, if I had 3.5, and then the notation for that would be like this vertical line. A very good one. So this would be the greatest integer function of 3.5 is actually 3. We round down to the next greatest integer. With the ceiling function of 3.5 would just be round up to the next integer 4. And so we're just rounding the values. So graphing a step function, f of x again is our y value, so we're trying to find our y value. Y value equals, and then we have this little brace here, and this brace just means the word and so we're including three different functions. Now we have the part here where we have like y equals -2, y equals -4, and y equals -6. Those are the three different equations. And the if part, this part right here is talking about the domain. This tells me the portion of the graph that we're going to actually see or graph the equation. So for this first one, let's do it color coded. First one here, we're going to look at this first one in purple. The domain, the x values are between 0 and 2. So 0 is right here, 2 is right here. We want to see the equation y equals 2 between these two values. Well, y equals -2. Y equals -2 is right here. So I want to see this line for the x values between 0 and 2. Now the other thing is, can it be 0? And it's or equal to. It's or equal to right here, so it can equal 0, so I should put a filled in circle here. And then at 2 it cannot be 2, so there's an open circle. Repeat that same process for the second one. So the second one, y is -4, and that's between 2 and 4. So -4, 2, 3, 4, probably should have went by 2s, but we'll keep rolling. So -4, and then we're filled in here at 2, and then open at 4. So notice how this is a function, because at this one vertical line, this vertical line right here, it still only hits one point. it actually hits this point down here. The other one's an open circle, so it still is a function. Then the last one here we'll do in blue. Y is -6 between 4 and 6. So -6 would actually be down here between 4, 5, 6 around there, and filled in, and then open. So this would be a step function graphed here. If you want to draw vertical lines for your domain, sometimes students will do that. They go from 0 to 2 and then draw a vertical line to section the graph up. You can do that and then graph the parts, and then 2 to 4, so 2 to 4, and then we have 4 to 6. And so you see the different sections. You want to see one graph within that section, within that domain. So why don't you have you tried this one? So you have 4 different equations with the domains they work for on a graph. So just sketch that out, and this is the one I want you to turn in at the beginning of class tomorrow so I can quickly check to see if you understand how to graph those. Piecewise functions. These are a little more complicated. Your same method, you still have the domain here that tells you what portion to graph. The issue is it's no longer a step function where it's horizontal lines. Now these are oblique lines, meaning they have some slope to them besides a 0. And so when we graph these equations, we can then draw the vertical lines that might help you out with some of this if x is less than 0. So the first one here is 0. So anything left of that. Then we have between 0 and 2. And then we have greater than 2. So we have 3 different sections we're looking at. The domain. We have one left, we have the middle here in the middle, and then we have one right. And so we want to graph this first equation, which is really like y equals f of x equals 2x plus 3. So using our knowledge, here is 3 our y-intercept. Now normally you'll go up to right 1, up to right 1, and keep going. But because we want this one to be graphed values of x that are less than or equal to 0, I'm going to go left of it. So I go left 1, I have to go down 2. Or you could say I want to go down 2, and then I have to go left 1. And we can keep graphing this equation. So here's the line we're graphing. Again, having trouble drawing a line for you there, Cobra. So let's go to the line. Now the question is, what kind of circle do we put at the end point here? Put a little arrow. Can it be this equation at x equals 0? And no, it cannot. It's got to be an open circle here because it's just less than. Let's graph the middle one. And this is y equals 2 for this domain. So y equals 2, up 2, y equals 2, between those two, between 0 and 2. It can be this value at 0, it cannot be it at 2. So make sure you're very careful about your open and closed circles. And then the last one here, negative x plus 1, which is a little bit more difficult because our y-intercept is here, but we don't want to see this portion of the graph. That's okay, we can use that, and then our slope is negative 1 over 1. I can plot points, I'm just not going to connect those points. And then down here, I can connect these points. Something like that, and then it can be here and an arrow going the other way. So that would be the step function. And then I could erase some of these lines so it's not too confusing when we look at the graph. These vertical lines that have no meaning there is helping us find the domain. And you don't have to use those vertical lines once you understand how to read these, so you know how to see the domain that you're actually showing the graph for. It becomes a little easier. There's a piecewise function. We can also use a piecewise function to evaluate. So we want to see f of -3. We're really asking the question is, what is the y value when x equals -3? So we actually plug -3 in. So what x value do we actually plug that in for? So you have to check the domain. You have to figure out where does your x value fit. Is it greater than or equal to 2? Is it between 0 and 2? Or is it less than 0? Well, -3 is less than 0, so I only plug it into this one equation. So I only use the first equation, and I plug the x value in. And if I do that, I find that my f of -3 is, and that's -6 plus 3, so -3. So that value, and then we can do another one, f of 5. Now 5 would fit in this domain, bigger than 2, so I plug it in here. So this would be negative 5 plus 1, or negative 4. And the last one would be if x is 0. For this one, equal to 0. Equal to 0 is this middle one. It has to be 2. There's no equation. It just is that value. There's no x to plug 0 in for. It just tells me if you have any x value between 0 and 2, including 0, your y value has to be 2. And that is it for tonight. And we'll see you tomorrow.